Hey everyone, welcome back, and in this class we are going to create a basic project into AWS, that is the AWS VPC. Okay, so if you're not aware of VPC, I will just tell you in short. So VPC basically stands for the Virtual Private Cloud. Okay, so it basically acts as like a private network for you guys. Okay, so if you're in a project or in any project and you want to create your own kind of network, and you want to create your resources into a VPC, or you want to keep those resources as a private, you want to use it just for the internal processing something, you don't want to make it publicly available. So in that case, you can just create a VPC and you can create all your resources which you want to create into that. So I will just give you a quick diagram how it will be. So suppose you have a region, okay? So AWS in region basically like data centers, okay? So this is the suppose we have the US East region, okay? In this US East region, suppose you are creating a VPC. So it will be your virtual private network, okay? And also in VPC, we have some components like if you have a VPC, so you create first subnets, okay? In subnets, you can have any, you can have public, you can have private, you can have both. That's completely fine. Any subnet which you want to create, any kind of. So we will be creating basically public only. Then you have route tables. Okay. In route table, you will define the routes, how the traffic will go. Inside route tables, you will have the routes. Okay. And then you will be having the gateways. So this also is having two kinds of internet gateway and the NAT gateway. And we are going to use only internet gateway as it's free. And NATO gateway, if you use, it will cost you. That's why I'm not including this into this class. Okay, so I will just let you know how it will be. So suppose this is the your VPC, and in VPC you can have subnets. Okay, so suppose this is the subnet in region 1, and this is the subnet in AZ2. Okay, in subnets you can have any resources, like suppose I have a EC2 instance, and here also I have a EC2 instance. So this subnet you consider as the public, and this one you can consider this as a private subnet. So subnet is basically the part of the network. So whatever VPC you will be creating, you will give some network range of private IP ranges like 10.0.0./16. So with 16 CIDR block, you will have from 2 raised to 16 IPs you can create. Okay, so and then you can divide this subnet based on this particular CIDR blocks. Okay, so next what we have. Mm, So this is the EC2 instance, and this is publicly, and you want publicly available. So if anyone want to access that, so or this EC2 instance want to access the internet, so it this traffic will go through the internet gateway. Okay, and then if you are using private, and if EC2 instances have been created in the private instances, but you don't want to use the internet, you want to keep the connection private. So in that case, you will be using the NAT gateway. Okay, so in this way, like our VPC basically works. So for our use case, what we are going to do, we are going to create a VPC, we're going to create a subnet and public subnet, and then route table, then routes, then gateways. In gateways, we will be creating internet gateway. So these are the things which we are going to create. Okay, and also the state management which we will be doing, that is the remote state only, which we have already done in the previous classes, but still in this class I'm again using it. So I have this bucket and a DynamoDB also available, so you can also create. Okay, so okay, let's move on now to the practical side. So we are just going to create a folder with Terraform workspace, not workspace, Terraform VPC we can write. Okay, let me just clear. Hmm, Here I'm just creating a folder with Terraform AWS VPC. Okay, and here we are going to just Terraform AWS VPC. Okay, cool. Clear the screen, and then here what we are going to do, we will be first creating a workspace with Terraform workspace list. So currently it will have a default only. We can just create with new dev. Okay, so if I do list, so we are on the dev workspace. Cool. So now what I have to do, let me just go there where it is. Okay, here. We will just create a file. I'll be creating some files, like first we will be creating main.tf, then we have provider.tf, sorry, then we can have variables, provider.tf, then we have variables.tf. We want to keep some variables also, then we want to have some outputs.tf, then we want to have some terraform.tf force to pass the values for the variables. Then we can have that last anything like backend.tf for the remote state. Okay, cool. So for backend.tf, already I have created a video on this. So we have a separate class, and here this one I'll be using backend.tf. Let me just copy paste things here. Okay, just I will be changing the bucket name. So bucket name we can just define into the variables here. So we can have variable, then we can give the bucket name, and then here also bucket. Okay, we can give the type equal to string. Okay, cool. Then in Terraform TF we can pass the bucket name, actually bucket name equal to, so the bucket name I have here is my bucket 632255. So I can just type it here, my bucket 622255. Cool, just save it. Then again we have variables.tf. In that also I will be creating some more variables, like variable region underscore name. This also will be typed with string. Other variable what we can have, we will be creating variable with the name of what we can create. Okay, we have some DynamoDB table, right? So variable DynamoDB underscore table. So this also the type will be our string only. So we can just write type equal to string. Okay, so these two more values will be passing here. So we have this region name that was basically US East 1, and then we have DynamoDB table that we can get it from the backend.tf. Yes, Terraform remote table hopefully I'm using, or I need to just check in tables what it is. Okay, it is some Terraform logs. Okay, we can just give the same name. Where is, okay, Terraform logs, right? Okay, so this is fine. Now we will just use these variable into this backend.tf file. So bucket we can use as what dot bucket name, right? So just clear this var dot bucket name. And we have the DynamoDB, so we can give as var dot DynamoDB table. Then we have region, we can give it as was dot region. Cool. Then we have provider.tf. In provider.tf we can take it from anywhere. We will have here down somewhere. No, this one we can use. Yeah, scroll up. Okay, provider.tf is also done. Then next we have outputs. So output we can keep anything like we can provide for now output region name, and then we can give the value as var dot region name. Okay, so output done, provider done, tf was done, variables done. Okay, so in main.tf, now the what we are going to do, we will be creating a VPC, right? So you just go on the Google, and if you type like AWS VPC Terraform, you will go on to the website of Terraform registry. So from here only we will take the codes. You will see the syntax also, and also you will learn how you can just do the Google and you can get the things done. So just copy this one, just go here, paste it. So here I'm using the CIDR block of 16. Instant tenants I don't need for now. I will just remove it, and tags name is there, that is fine. We can give the name as VPC TF, that is the Terraform. Okay. So VPC will be created with this name and with this CIDR block, and then next what we will be doing, we'll be creating a subnet. So now next search for the AWS subnet Terraform. So for this also you will get here. You can scroll down, and here you can see you can provide it for the subnet VPC ID and the CIDR block and also the name. So even if you do here the same thing like resource AWS underscore subnet, then we can give as subnet, we can give it as name as the public subnet actually. Okay, so here we can provide the VPC ID with the AWS VPC.main.id. Cool. Then we have the CIDR block, so that also we can give as 10.0.0. Sorry, 1.0/24. So it will have some 10 2 raised to 8 IPs. Okay. Then also we have tags also here. So just copy this thing and I will paste it here. Name we can give as public subnet. Okay. So we have created the subnet. Then we have in subnet we want to like uh, create a route table, right? So we will be creating that also. You can do just resource or AWS underscore route underscore table. So there's difference between route and route table. Okay, so route table we will first create, and inside that whatever route we will create, that will be AWS routes. Okay, so route table we can give here, just remove it. Here also you have to provide the VPC ID, I guess. Here something mistake is there, I guess. Let me just create it again. Route underscore table in name route table, and then VPC underscore ID. The same we can give VPC main dot ID, right? Here you can give the name as public route table. Okay. So if you search this also you will get, so AWS route table Terraform. if you go down, or here also you can see from the Gemini VPC, we can just pass it. Next we have the route also. Here you got the route also. So resource, it is route, internet route, destination you can see, and the gateway ID for this internet gateway. Okay, yeah. So first we'll be creating a internet gateway also. So resource AWS underscore internet gateway IG we can give, and then here also we need the VPC ID. So where we want to create our internet gateway. So in this ID we want to create, then we can give the tags with name, right? Name we can give as internet gateway TF. Okay, so that is done. Then we will be having the route. So let me just copy this thing. Okay, so here we can just have the route table. Can just remove this all. AWS underscore route table dot ID, and same here we will have internet gateway dot ID. Okay, cool. We'll just remove this. Okay, so now we have almost everything. VPC we have, subnet we have, route table we have, internet gateway we have, then we have the route also, right? Okay, so that's nice. So what are the things we saw here? Okay, subnets, public, route table, route, gateway, internet gateway, yeah, all done. Okay, cool. So now what we are going to do, we are going to simply do a Terraform plan, and it failed. Why it failed? Let me just check. Sorry, we need to do first initialize, right? I didn't initialize. Okay, so here it's failing somewhere at backend.tf what dot region. Why variables not allowed? Okay, we can't give the variables. That's fine. I'll just remove it. Whatever it was here. If I do control it, will it work? Yeah. Okay, here we have just provide the Terraform logs, right? Okay. So main.tf outputs. Okay, in outputs we will be providing output of all the required things. Output VPC ID we can give value equal to AWS underscore VPC main.id. Cool. Next we can provide ID for output subnet ID. Then we have output equal to AWS, sorry, value equal to we have here AWS underscore subnet public subnet dot ID. Okay, this one we will be just printing. So let me just do now Terraform for a minute. Okay, we got some error. Uh, the parameter dynamo DB is typically use parameter use log for instance. Okay, fail to get existing workspace S3 my Terraform log 6547 doesn't exist. Okay, where it is? Yeah, so bucket name I have to change. My bucket 632255. Okay, let me just I can copy from variables now. TF4, right? Simply just remove it and paste it. Yeah. Okay, now let me just initialize. That should be done now without any issues, hopefully. Okay, initializing provider plugins. So it will take a few more seconds of time as we are using the remote state. So it will take some time. Till then, I'll just pause and I will come back. Okay, initialization is done. Now it's time to plan. Okay, acquiring state lock. This might take a few minutes. Okay, plan is done. Now we have to apply. So you can see VPC ID, subnet ID is the name we are get to know. And we have how many changes? 5. Okay, here you have to just enter yes. And you can see VPC is getting created. Oh, creation completion. Okay, done. Internet gateway route table. Oh, nice. So everything is done. We have, you can see the subnet ID, VPC ID. So all resources has been created. If I go back here into my console and if I search for here VPC, so I should be able to see my VPCs. So in my your VPC I will go. Okay, it's loading. Okay, cool. So here you can see the VPC TF. So if I click on VPC ID, you can see all the information right here. So you can see the flow also, like the source map. This is the VPC. This is the subnet you have created, and this is the route table. That is the it gets created every time. Okay, and then we have this public route table TF, and it is connected to the internet gateway. Okay, but one issue we have here is like this public subnet is not connected to this route table, so that also needs to be done. So let's do it. Okay, so for that we have one AWS route table association. So resource AWS underscore route underscore table association. Okay, what happened? Something happened. Resource AWS underscore route underscore table association. Yeah, name we can give route table RTA. So here we can provide the VPC ID. So VPC we have here as okay. Oh, we're giving VPC ID only, right? But why it's not showing me? Okay, let me just check what it is. We can just do Google here. Route table association Terraform. So here what we have subnet ID and route table ID. Okay, so we can just go here and give the subnet ID. Yeah, AWS underscore ID. Then we have the route table ID. Route table dot ID. Cool. Now I'll just apply and then it should work now. So if you will see our VPC, then it will you can see the mapping there. Requiring state lock. Okay, refreshing state. Want to edit? I can see now here. Okay, It is done. Okay, let me just go back here on the screen and let me just refresh. So if I will refresh here, I should be able to see that particular route. Okay, so if I go here and now you can see the resource map as public subnet, which is associated with my whatever route table which I created, and that is getting attached to the internet gateway. Okay, so in this way you create the VPC in our using the Terraform. So that's it for this class, and I will see you in the next one. Thank you so much for watching.